Hey guys, in this video we are going to be constructing sinusoidal functions. In other words, we're going to be writing an equation given information. So in this case, the information is the midline, where the graph crosses the midline, and the maximum point, or a maximum point, right? There's an infinite number of maximum points, but we're given one of them. So, and we're assuming we're given the first one. We're just because it says and then, so it crosses the midline and then has a maximum. So this is the next maximum after this midline, after this time crossing the midline. So let's make a sketch of this to start with. So you often, pretty much always, when I'm given information like this, I just sketch the graph because I feel like that's the easiest way to visualize, right, the information that I'm given. So 0, 5, let's say that's here. So that's where it crosses the midline, which means the midline looks something like this. So the midline goes through that point. So the midline is going to be at 5, y equals 5, and it intersects with the graph here at 0. So which function, sine or cosine, crosses the midline at 0? Well, hopefully you remember from the last video that would be sine. Sine crosses the y-axis at the midline, whereas cosine crosses the y-axis at its maximum or minimum. So the one thing that I know about this equation already is that it is a sine function. So I'm going to start making notes over here of what this equation is going to look like. So I know it's a sine function. That's the first thing I know. Now I have a maximum at pi and 6. So I'm just going to call this pi. Just going to call it pi. And 6 is going to be right there. So one period of this thing is going to look something like that. We're going to go up to the maximum, back to the midline, down to the minimum, and back to the midline. That's going to be one period of a sine function. Up here at 6 is going to tell me what my amplitude is, because the amplitude is just the distance from the midline to the maximum. So I'm going to look at my y values, 5 to 6, right? If I'm going from 5 to 6, what's my amplitude? Well, it's 6 minus 5, which is 1. So my amplitude is 1. That would go right here in front of the sine function in my equation, but I don't have to write it because it's just an invisible one. So I'm just going to write myself a note that the amplitude is 1. I found it. That's all good. Oh, forgot to write the midline. The midline is at 5, so I know that I'm going to have a plus 5 at the end of my equation because that's what tells me the midline. So I know I'm going to have a plus 5 at the end of my equation. I know there's an invisible one here. All that's left to do is figure out what my period is. So that's kind of the trickier part of this. So there are a couple ways to think about doing it. The first one might be to say, okay, well, I know this distance is pi, and I know that this distance is the same, and then that distance is the same, and then that distance is the same. So from here to here is pi, plus another pi. This has to be 2 pi, plus pi. This has to be at 3 pi, plus another pi. This has to be at 4 pi. 4 pi. So my period is 4 pi. So 2 pi divided by what gives me 4 pi? Gives me 4 pi. Because remember, to find my period, I take, let's not use x. X is confusing. Let's call that b. So 2 pi divided by b gives me 4 pi. Because remember, whatever I'm putting in front of my x in my equation, 2 pi divided by that gives me my new period. So if I do 2 pi divided by what gives me 4 pi, multiply both sides by b, I would say 2 pi equals 4 pi times b. You might already be able to say, okay, b is a half. I know that. But if you can't see it, just divide both sides by 4 pi. Pi's cancel. If you reduce 2 over 4, you're going to get 1 half equals b. So I have 1 half x here. And that would be my full answer because, yeah, we've accounted for the 3 things that we know to look for so far. In the next video, we're going to be talking about phase shift. So that is the same thing as a left-right translation. So we're going to be talking about that in the next video. But for this one, it's just going to be midline, amplitude, and period. We're not dealing with a phase shift. And even if we did have that possibility, we would know that there isn't one because we know that we cross the midline when x equals 0. So that's a sine function without a phase shift. So this is our answer. But before I move on, I want to talk about a second way that we could have figured out this 1 half. That second way is to compare this, what we know here, to the original sine function. So the original sine function looks like this, where this is 2 pi. So half of that, this point where it crosses the midline, is going to be pi, which makes this maximum pi over 2. So the maximum is originally at pi over 2. Our new maximum is at 4. No, it's not. Our new maximum is at pi. I don't know why I said 4. Our new maximum is at pi. So to get from pi back to pi over 2, what would I have to do? I'd have to multiply by a half. So that's what would go here. So you can use just the information you have and do it this way, or you can compare it to the original. Say, okay, what would I do to this pi to get back to the original point, which was pi over 2? Well, I would have to multiply by a half. So that goes here. The only danger with this is not knowing these points, so you might have to figure them out. And also making sure that you're comparing the correct points. So you have to be comparing this maximum to this maximum, this first maximum after the y-axis. Or if you were given this point, make sure you're comparing it to this point or whatever. So just making sure you're comparing the correct points, and then you'd be fine. So the logic is, what would I have to multiply by my new point to get back to my old point? And that's what would go here. So pi times what is pi over 2? Well, that would be 1 half. And we already know that that's true because we proved it over here. So either one of those methods would work. And now I'm going to type it in. So sine of I'm just going to do x over 2. I would generally write it 1 half x like this, but when I'm typing it in here, x over 2 is fine. I feel like it's less work. Plus 5. All right, so let's look at the next one and see if it's different. This is the same. It would just be a minimum and the midline. So this time the minimum is at x equals 0. So if the minimum is at x equals 0, this tells me 2 things. It tells me that it's a cosine function, and it tells me that it's negative because it's the minimum that's on the y-axis. So if the minimum is on the y-axis, then it is a negative cosine function. So let's sketch, oops, I need my pen. Let's sketch that out. So my minimum is, let's change color. My minimum is here at 0, -3. My midline is at 1, 1. My intersects the midline at 1, 1. So that is going to tell me a lot of information. But first of all, like I said, this is going to be a negative cosine function, and I'm leaving myself space because I don't know what the amplitude is yet. Speaking of which, all right, so I have a minimum and I have the midline, so I can figure out my amplitude pretty easily. It's going to be the distance from -3 to 1. So 1 minus -3, which is 4. So this distance is 4, so that's going to be my amplitude. So 4, amplitude is 4. And my midline, like I said, is at 1 because it's the y value of this point where it crosses the midline. So I'm going to have a +1 at the end. So again, pretty straightforward until we get to the period. That's the last thing we need to figure out. So we started at the minimum, so we're going to go through the midline, up to the maximum, back through the midline, and we're going to end back at the minimum, because remember, it's maximum to maximum or minimum to minimum. So in this case, it's going to be minimum to minimum. This distance in the x direction is 1 because I was told that this is at 1, which makes this at 2, which makes this at 3, which makes this at 4. So my period is 4, which means that 4 equals 2 pi over b. So I'm going to multiply b to both sides. 4b equals 2 pi. I'm going to divide by 4. So b equals pi over 2. b equals pi over 2. So here I have pi over 2x. That's what's inside my cosine function. All right, the other way to figure that out, so that was one way to figure it out. The other way is to know that cosine or negative cosine looks like this. So I can compare it to negative cosine, that's fine. With this would be 2 pi, which means the maximum here would be at pi, which means this would be at pi over 2. So what do I need to multiply by 1 to get back to pi over 2? Well, pi over 2. So that's what I put here. So again, that's the other way to figure this out. So that's it. That's all we need to know for this one. So I'm going to put -4 cosine, that's not an S, cosine pi x over 2 plus 1. That is how you construct a sine function, hopefully, a sinusoidal function, general sinusoidal function. Hopefully that helps. Let me know if you have any questions, and I will see you in the next video.